Yes, we are live.
Fantastic. Yeah, Anuj, if you, I mean, I can maybe just give background on this article. I sort of ran into this with a friend of mine shared on LinkedIn, and I thought it was interesting, like a description of a POC, like a simple proof of concept of a particular design. But I thought this could be more generalizable. I thought it was interesting. So maybe you can go first, Anuraj, and yeah, share your thoughts.
Well, I didn't understand what special they are doing with the regards to the CAD modeling itself, how the like model is working. But I've been looking for something related to like uh, CAD design, specifically mechanical CAD with LLM integration. Because I'm not a mechanical engineer, and like since I'm building robots, I still need to have some basic uh, mechanical engineering CAD design skills, and like I have been trying to gain that skill for a long time, but I've never had time. So like I've been waiting for something in which I could write in English and then basically like get the basic STL done, and then maybe I can improve upon it. But if I start from scratch now, then I will have to do a lot. So I've been waiting for something like the kitty cat. So it basically like you can, it's like there is a script on the side, and then you can model with Python script or something. So something like that. But yeah, the tools are still not there yet. But hopefully it will be there in a year. Then I don't have to learn go through the learning curve of these CAD tools. But this seems interesting, but like I exactly did not understand how it reduces the automotive design cycle itself, because doesn't it require like a high fidelity simulation to actually make decisions or something? Yeah, those were my initial thoughts.
Right. I mean, I am a mechanical engineer, but I still uh, I can't claim any good proficiency on CAD either. I would like an LLM for CAD design myself. But yeah, this one was interesting because they are more focused downstream of the workflow, not at the CAD level. So they're more focused on the simulation and analysis of a CAD design, and the sort of CAD design that they do when they sort of start with a base model and like a base CAD model, and then they have like a few parameters. So they make the CAD parametric, whether thickness or height or some shape or some perforations or some of those features, so to speak, CAD features, so to speak. They sort of parameterize them, uh, and then now they have like a design envelope, right? So you have like a bunch of parameters that are uh, dependent on each other, and that affects the outputs, and the outputs they are looking at are just simple, drag on a moving body like a car or some other, it could be anything really, but they use car as an example. So the way, what I thought was interesting was they first ran a bunch of simulations just like high fidelity, and there is no shortcuts there. They ran the actual physics, and they now then had like a bunch of training data, and then they used the training data to train a couple of models, and they call the models as like, one is the, what they call as the mesh graph nets. It's kind of uh, my understanding, at least from just superficially reading the details of the mesh graphnet model, it seems it's a model that can store uh, uh, information on the nodes and the faces of the cells, like the way the pressure and velocity and other variables are stored is in a graph-like structure, right? So uh, they can reduce that. I mean, they can, with the trained initial set of simulations or whatever the parametric simulations they ran, they could then train this graph mesh graph model to do some sort of interpolation, so that you can also predict the same field variables, whether pressure or velocity, at new unknown locations that was not part of the simulation, right? So if the simulation had like probes or sensors at say 10 points, and then you train the model using this framework, and then now you can prompt it to find the values at a new location, and it's kind of instantly gives you the value, right? So you don't have to run the simulation again, and that they claim is about within 2.5% error range, right? The drag estimation as a result of this model, which I thought was not bad, because if you think about like running a simulation, it takes like few hours, like 6 7 hours, and there's a lot of cost, all the things, and the fact that this can predict uh, with the initial training data for new designs within 2.5% accuracy, it seems pretty reasonable, and that's how I presume that they claim that it can cut down design cycles, right? Like over long, uh, instead of 6 hours, now you can get almost instantaneous prediction, and it's kind of uh, because it is within 2.5%, you can then start looking at making modifications to the CAD without running the simulation. And then once you sort of are within the range that you are happy with, then you can run the high fidelity simulation. In fact, they say you can then run the actual wind tunnel simulations too, which is sort of how they actually validate it, right? So I thought that's how they claim that this can cut down some design cycles, which I thought was interesting. The other one was uh, what they use a CNN, like a convolutional net for predicting pressure and velocity, which is also quite complex. And they used H100 GPUs for it, and they trained it for 28 hours. So there is an initial sort of time that they have to spend, like they have to spend 28 hours running the GPU training these models. But post that, it seems similar to drag. It can predict velocity and pressure within like 3 to 5% accuracy, which I thought was also interesting. I mean, the last part of the article, the business value creation, is just like they are sort of marketing themselves for other companies to take advantage of. But thought the overall, the way they describe the architecture and how this one particular simple use case can work, I thought was interesting. But it did leave me wonder on like the machine learning models they used are not that fancy in the sense that they are basic models with structured data. Uh, I did wonder if how where would LLMs fit in, uh, if they do fit in at all in this workflow. Maybe in the model building phase, maybe further downstream in post processing. Uh, and could be. I thought it was interesting to think about how LLMs could work with you know specialized machine learning models such as these, like the graph. What they call it, the graph usenet or something, and then the other one. It reminded me. I mean, the other reason I picked the article was it reminded me like the few weeks ago we read the Stanford AI report, and that had like a example for flexi cubes, where they were generating like a smaller and smaller meshes without sacrificing the fidelity of the geometry, so you can still visualize them neatly in a three-dimensional way, but without having to really generate a fine mesh, and that will create a load on the computer in rendering and stuff. So I thought this was in line with that, and with a more specific use case. But I'm curious though, Anuraj, with your sort of background, like how it might be. I mean, maybe I'll just let Jenna go first if Jenna wants to speak, and then I can ask my question.
Finding the mute button. I think that you could have just asked your questions. It's a nice small group today. But the two things I would add to this conversation, which is for a couple of years, I've been helping a client who's doing exactly this massive CFDs, but for ship hulls, having to do with efficiency for big ships moving through the water. And I saw firsthand how it could be 12 hours in their case. So you get one or two runs a day, and that they set up so that somebody's working at night, so that they could keep these expensive machines running. Um, on the other hand, two concerns for me. One is for all of these tools, I still think the jury's out on whether they're gonna continue to improve at the rate that they've been. Like of course they're gonna flatline eventually, but I'm wondering about a hard ceiling that they'll only get so good, and then that there's something unsolvable that we're going to run into, and then we'll end up with what think is I see other people talking about this, but the problem that autopilots and planes have. So if your auto tool is, the closer it gets to being perfect, the harder it becomes in some ways to actually use, because you're just going to go to sleep, and catching the one, if it's just 1% of the time that it's wrong. I had a major breakdown at night on a major highway in New York City, 10 o'clock at night in the dark, because the heat indicator on my car, unbeknownst to me or unnoticed by me, had started to go up. And so I'd been driving at that point for maybe 20 years. And finally, this gauge that had never moved in all my life started to move, and no, I didn't notice it. So suddenly, there I was with a radiator that had exploded at night, and so I really feel that as a visceral problem. So um, that's one of the concerns. Are these tools going to get us close, but still so far? Like and to your point about 2.5, not able to assess, but is that pretty darn good, or is that still miles away from being useful? So the basic idea, yeah, I would love to speed up cycles so that you go to the CFD only once you think you've got something that really is worth the 12 hours runtime. And then the last piece I'll just say is about this, is this piece for real or is it a marketing pitch? And Anuraj, thanks for explaining HPC. But honestly, that's the kind of an expression only marketing idiots would use, not real people. So that they used it without even explaining it. I really was expecting something much more technical. So that's to me almost a tell that this isn't real. But I don't want to overstate my position about that either. But it's like, oh, right, maybe this is just they want you to use Amazon's compute setup. So with that, I'll mute and hand back to the team.
About that scaling issue you were talking about, Jenna, I think Arvind Narayanan, the guy from Princeton who writes the AI blog, I think he had a recent article like speculating that the companies might already have reached the scaling potential, and that's why they are not releasing new models anymore. And basically, like the first, I think GPT 3, the like the gap between 3.5 GPT and 4 was much less, and now people have been waiting for GPT 5, but it has not been released, and they are releasing versions of GPT 4. So he was speculating that
Yeah, I may have seen that
yeah,
somewhere. Can you
yeah,
say
yeah.
his name again, Anuraj? I missed it. Can you
Ar-
say his name again? I missed it.
Arvind Narayanan.
Okay. Yeah, drop a link in the chat,
Yeah,
obviously, if
yeah.
you can put your
I
hands on
think
it.
if
Yeah.
I find, I think I think his Substack is called AI Snake Oil or something, or how to detect something, or he has written a book about it, something like that.
Yeah, we're close.
Uh,
We may already be
Yeah,
reaching the, what do you call it? The asymptotic. How do you
yeah.
pronounce that word? I don't say it out loud.
But HPC, I think that blog, this article is coming from something called AWS HPC blog. So I think this is specifically marketed to people who work in this area. So it's like a common acronym. So yeah.
Yeah, I mean, I think HPC is like a commonly understood. At least my sense was, at least it was a commonly understood term for connecting large compute clusters together, right? Running a distributed, like running the simulation on like a distributed set of computers. And that umbrella term to describe that, I thought was HPC.
They explain all of their other acronyms that they throw out. So yeah, this one they just assumed everybody would know, but it still doesn't really. What you just said wouldn't have taken very many words to say. So is it really the shorthand that everybody's using when you mean complex compute clusters? It's fine. It's just something that occurred to me.
But I mean, the ship hull example you mentioned, Jenna, I thought this could be. I mean, the architecture described here in this article could be applied to that particular workflow, right? In terms of one of the issues, at least I mean, I talked to a few of the engineers who do some of these simulations uh, in companies where uh, in different like bike companies or different consumer electronics companies and stuff like that. And one of the things I've heard engineers talk about is the expertise to do simulation is typically siloed within the R&D side of the house, and the design where the main CAD design happens and all the bill of materials and all the other sort of the PLM aspect of all products happen. The engineers that work with those tools often don't do simulations themselves, and they sort of uh, pass on the designs to the simulation experts to do the simulation, and that kind of slows down the design cycle. Apart from just having to run the model, it's also like there's a lot of exchange of hands happening because of siloed knowledge about simulation and so on and so forth. So I thought this is something like this could provide the design engineers more upstream of the process, more ability to have an intuitive sense of the impact of their designs. If they're making some changes, how is that going to affect whatever the KPIs that they might be monitoring. So that might be an interesting way to leverage this to save some time in just the engineering iterations.
Yeah, if it worked within some definition of it's working, it's 2.5%, like you said, it would be incredible actually. From the project that I've been helping with, would have saved them a ton.
Actually, it might be useful in reducing the design space. Like you iterate coarsely on a large design space, and then once you have found out, and then you can go for high fidelity. I don't know why they have reversed it. Like first they are doing high fidelity, and then they are going for the LLM or like the machine learning part. There might be a
It's a great
reason, but
point.
yeah.
One
I guess
one
that
thing
was
you
the
guys might,
data that
sorry,
they needed
yeah,
for. Sorry.
please.
No, I meant that I think that was the reason they went that way is I think they needed the synthetic data set to train the machine learning model in the first place. So they had to run these high fidelity simulations to generate the data set.
Here's my question for you too, because I bet you know how we say ELI 5? I've settled on like ELI 16. Talk to me like I'm a reasonably intelligent teenager. And what is the difference between all the modeling that's been going on for decades now and this? Like, what is the step change? Uh, um, is it because there's this weird voodoo black box at the center of all LLMs that it just does its guessing in a way that's new? So that's my current wondering about why it's actually different.
Uh, I can go maybe. I can take a shot. I'm not sure if I have any clear answer for this, but at least my understanding is that this is a continuation of the sort of 2012, 2011, the big paper that Google published on like the unreasonable effectiveness of data, big data in machine learning. I think that's something along those lines where they just dump more and more data into like a conventional, I think CNN or other types of traditional basic architectures, and that sort of was on a improvement trajectory. And with the attention is all you need in 2017, 2018, the sort of underlying training architecture changed, but then the overall pattern of just dumping more and more data for like a probabilistic distribution of outputs, that principle remained the same. And it seems the attention, the transformer mechanism is just so powerful that it can, uh, it seems it can get very good on like more data, like more, huge volumes of more data. So that's sort of my
Thank you. Yep.
understanding, 16 understanding. But yeah, Anuraj, maybe some more detail to that.
Uh, so your question was regarding this specific use case, or was it just generic?
I think that it's the transformer, like the thing at the heart of this kind of modeling, as opposed to all the other modeling we've had around for a long time, is this. That's my shorthand. It's like the black box magic at the center of attention is all you need. There is something qualitatively different about it as a
But
modeling tool. Does that sound
do
right?
I don't think we really understand, right? Like how exactly the but everybody knows uh, that
Yeah,
the
that's a black box, right?
yeah, once the parameters are found, like there are like trillions of parameters, and then once they are found, the weights are found, you can do inference on it. But why exactly it works, I'm not sure if we know it. Yeah, maybe somebody
Do
more
we know
knowledge.
much about do we know much about reproducibility? For a lot of tools, if you ask it the same question 10 times, you'd like to get the same answer 10 times. And with this tool, you kind of are enjoying not getting. You're going to get a different answer every time, kind of, right? That's one
I
of the
think there has been
weirdnesses.
some improvement on that. So recently I've been seeing this uh, consistency of answers. So like at least in the image generation, you can have the, so lots of people are making Instagram accounts in which you have the same character but in different uh, doing different stuff. So a mechanical engineer, but the same character would be doing different things. So that has already
Oh, right. So
been
you can hold one part of it constant.
yes, yes.
Yeah.
So the same person would be doing different activities. So that is already, I've seen that on Instagram. So people are using it to generate. different kinds of images. But when I tried it, was it 4 5 months ago? I was not able to do it. So it would always generate a different
Mm.
image, and then I would not be
Yep,
able
yep,
to
yep.
get it back. But I think there is some tricks. There are some tricks now with which you can do it.
And in the article today, I missed it if it went by. Did they talk about how whether they were how reproducible their results were?
I don't know. Maybe Anant can talk about it.
Uh, I think they mentioned that when they uh, make changes to the design that was not part of the training uh, data set, it's, I mean, they had some levels of accuracy, but I'm not sure if they tried a lot of different design variations. But the way they at least shared the output, it seemed that it is generalizable, the output percentage ranges. And the other thing, they didn't quite use the transformers here, right? At least that's my understanding. They used like more old-fashioned neural network architecture for this, because one is structured data in the sense that uh, it's a graph data, right? It's a node, and each node has some value, so it's kind of very constrained, as opposed to like a random strings of texts that transformers would have to deal with. So I'd imagine that may contribute to some deterministic uh, outputs. But yeah,
Oh, that's the word, deterministic. Yeah. Hmm.
I mean, there is this whole field of mechanistic interpretability that I kind of ran into recently. We tried to do, I mean, I guess I shared an article link before, but we haven't read. Maybe we did one reading. I'll try to find it. But it seems this field of mechanistic interpretability is sort of a way to interpret the results of these transformer-based AIs, and to kind of form causal relationships between prompts and outputs. But I'm not sure. A lot of people seem to have very strong opinions as to this is like a non-starter, that you can never do this because the underlying architecture is so random. But there is an
Yeah.
sincere effort within OpenAI to do it. So
No, really. I mean, I appreciate this reading. It just gets at kind of this core. Are we in the middle of like a change, history making moment, or is it another flash in the pan that the tech industry is so good at building up and hyping and before the collapse? But I also didn't mean to hijack the whole conversation. You guys probably have more technical things that would be fun to talk to each other, so I can just mute and enjoy
uh,
that going by.
I mean, no, these are questions I
I don't.
had myself.
I I don't have
Okay.
much interesting things to say on this topic because it's well, I don't know much about
Well,
mechanistic
if
I do
I'm
have a question
16,
for
you guys
you.
are if I'm 16,
uh,
you guys are like at least 26. I'd give you
uh,
36 and 46.
I mean, so if when you saw the sort of the way they model this, or it's just like for it's like a design optimization problem, multi-parameter design optimization problem, right? So you have multiple parameters with competing interests. So is this type of workflow uh, applicable to embedded design or other types of simulation that you might have to do at the hardware level, or how
Well,
useful
at
or
least in
this
electronic
might be?
design, I've seen there are people trying to use this. So, at least in Yakrova project, we were exploring this tool called Flux AI. So they have on the back end integrated the LLM into the electronic CAD design software itself. And then you can ask questions about, okay, where will this component go? And then if this pin of this chip, where should I connect to the pin of the other chip? So you can ask questions like that, and then it will tell you, okay, this pin will go there, and that pin will go there, and this will be the voltage there. For simple circuits, I think it works. So people are already exploring that.
Right. Is simulation a bottleneck at all for electronics hardware design, or
It
is simulation?
depends. How complex the circuit is. So for example, if you are doing let's say high frequency design or some radio like Wi-Fi chip design or Bluetooth, then you need to at least some companies, small scale companies will need to do simulation. So they do simulation of the antenna, uh, EM radiation simulations. And actually that also goes when you want to get your product certified, it also goes to a lab to get the uh, that checked, the actual EM radiation checked in a lab. So you have it in a lab, and then there are like it's a closed room lab. It's really interesting. So you basically place it in a Faraday cage, large Faraday cage, and then there are like detectors on the large room, and then you turn on the device, and then it will be able to measure the amount of radiation that is coming out. And with that, the lab can certify, okay, this is certifiable for this class of radiation. And basically the first iterations are done via simulation software. So there are like specific software for like designing these sorts of chips.
Right.
And yeah, high
Interesting.
speed circuits also, like when you have like high frequency uh, circuits in which because like uh, when you have high frequency square waves or any digital signal going, it will emit radiations. So you have to design the PCB in such a way so that it doesn't emit more than the specified limits or whatever the agency is specifying. So even that requires some simulation. And yeah, I don't know how much of LLMs can uh, help in that, because I'm totally clueless about those fields.
Right. Maybe precisely that's where they can help. Like they can guide you, like sort of on how to go about running the simulations or building the simulation models. Right. Yeah. I mean, I didn't have anything else other than I thought this is also interesting from the other perspective of like the uh, HPC, or at least the cloud HPC, the way the article described it. I see it as like on the other end of the spectrum of like the blockchain based computers, right? So it was interesting to contrast them in my mind, at least on the bandwidth and the blockchain computers are so basic. Like they can do very basic things. This is like we are trying to push like huge GPU clusters through the internet through the TCP is how they configured this architecture. So I thought that was also interesting.
I do have one more question for you two. Do you feel like the article explained enough that if you wanted to, you could sit down some weekend and fire this workflow up? Or is it like, hell no?
Not for
Uh,
me. Well, I can handle
I think
the AWS part, but not the mechanical engineering part.
right. No, thankfully, so the mechanical engineering part is actually not that hard in this one. The AWS configuration setting part might be the hard one for me. But I think they mentioned all the frameworks they use. They mentioned all the tools they use, all the AWS services they used. So it's like almost feels like a recipe book. So you should be able to, with competent, better, more competent than me, people should be able to hack together a solution based on this.
Right. It's bolting together, what, 8, 10, 12 different things. But once you've bolted a few things together, it does get easier.
Yeah,
Yeah,
but
I mean, for
then
what
it
it's
also,
worth, though.
yeah, go on.
No, I was going to say I've seen setups like this and other, like Jobby Aviation is this like startup company. I remember them presenting in some conference on how they made their custom AWS clusters with custom job submission, job schedulers, and things like that. So it seems people have done it. So it's, if I think in that order, it seems like this is a recipe book to include the machine learning models via the AWS SageMaker, which is the kind of the new component that they seem to introduce here.
You guys may have seen Venkat did a post, I think it was last week's maybe, where he just sort of was messing around with the word monolith. And in this group, probably 2 years ago, I learned for the first time the word composability. And so I see now this is this great pendulum swinging back and forth. Composability is cool. All these little pieces that you can join together and do something neat. And then there's an essential fragility to all of that. You got that software engineer in Nebraska whose piece falls out and your whole thing falls apart, and which makes you more excited to have a monolith again. Am I onto something? Like, this is one of the great pendulums that's going on right now.
About that composability and the thing you're talking about, bolting together things.
Monolith.
So
Mm-hmm.
yeah, so basically what happens is like when things become sufficiently complex and there are like multiple things you have to bolt on together, you basically need a specialist who is like specialized in bolting the stuff together. So like that is kind of what I do
Yeah.
for embedded, right? So in embedded there are like
Uh-huh.
there are like hundreds of options, and there are like, for I work from the transistor level and then to the PCB level, then there is like system on chip level, RTL level, compiler level, assembly level, C level, Python level. So there are hundreds of options for each of them, and then basically
Yeah.
you are choosing what is good for a particular application. So and so basically that itself is a specialization of what to bolt on together. So for example, now I think there are like specialists who are just specializing in AWS cloud compute. They're like they even provide certification for it, because now there are so many options in AWS. You actually get confused when you are just starting out. And I've seen consultants who offer AWS consultancy, who are just helping you figure out AWS.
Yeah, I've seen that. There was a whole firm that just helped you
Yeah.
optimize your spend, your AWS spend. It was easy for it to get way out of control.
In many ways, robotics is also something similar. So you can have specializations, but you will need eventually a bolting specialist.
Hmm. Oh, neat. Yeah. A reading that the OGS group did a long time ago called used the term a glue person. You need a
Yeah,
glue
yeah,
person.
yeah.
Hmm.
Basically, a glue person. That is a good term.
Well, especially now that I know I have a new word. I'm going to say it wrong. Viscoelasticity. Did I say it right?
Yeah.
I haven't heard.
Viscoelasticity. There was a YouTube video that this science engineering nerd explained duct tape. It was turned out to be actually really interesting.
Yeah. Viscoelasticity reminded me of viscoplasticity, that it's often like a failure mode for chips and electronics.
Oh.
Like the solder ball, the solders that the chips are connected, they often fail by viscoplasticity.
Oh. Really? So I'm trying to picture, because they're not normally under physical stresses, or is it just the heating and cooling of like a normal work cycle enough for them to snap sometimes
Yeah,
and break?
precisely. They
Got it.
accumulate because of the work cycles, and they break at some point, which
So
is
what was
like a
the
very hard.
read? Go on.
No, it's just
No,
like a very extremely hard calculation to do.
I was just asking what was the reading for that glue person. How did that?
I probably can find it. If
Okay.
I don't, do it in the next half hour, just remind me.
Yeah.
If I get distracted, I probably can find it. It had more to do within an organization. It's kind of what we don't have, or it's kind of what the role I have sometimes in the Yak Collective. I'm not the best at anything we do, but because I hang around, I have institutional memory, and I'm able to make connections sometimes. That's helpful.
I mean, talk of glue reminds me of one of my other, like its recent favorite readings, the Fork Time and Glue Time. Uh,
Oh, I don't think I saw that one.
there was a
Say a
while
little more.
ago. It was called, the title of the article is called Fork Time and Glue Time, where he
Oh,
was talking
I haven't
about
heard it.
you could have two different types of time, where, like, if you have fork time, everything is like siloed and individual, and glued is sort of like the domain of uncertainty, and you need a glued time to keep that uncertainty going, or like the status quo going. At least that was my understanding.
We're always just guessing when we read him. But yeah, good.
No, yeah, I was saying my understanding, and I think yeah, the article is
Yeah.
you said that.
Well, are either of you doing LLM work in your daily life? That's always fun to find out if you're using it to like help write emails, that kind of dumb stuff, or anything actually more interesting and useful. But in the little time we've got left.
I use it like a Stack Overflow, interactive Stack Overflow.
Yeah,
For coding. Yeah.
Yeah.
I use it to learn any concept, any paper. I use it like in many different ways. Uh, yeah, it's like almost become the application that I spend most time with. Outside of
Oh,
yeah,
it's a real like partner in thinking. I've heard
yeah.
of that. People getting. And so which ones are you guys settled on, for the moment? Claude, ChatGPT,
For
Perplexity, what else?
live web search, Perplexity seems to be good. Uh, ChatGPT for more. Uh, uh, like I upload PDFs or I give it more specific context to chat with.
Yeah.
So I've been using it.
Yeah.
I did try Gemini, but I'm like in two minds if I want to pay for more than one of these things. I pay for ChatGPT today, and maybe I'll try to switch it up in some time.
Yeah, I use
I
the
will name drop.
free version of Gemini and then ChatGPT. I don't know how long will I continue paying for ChatGPT, but at the moment I'm paying probably. I know
All
many
three
people
of
who
us
have
are
stopped.
thinking about giving it up.
Yeah, I know many people who have stopped using it and they started using the free versions.
Yeah. I will name drop Raycast. I don't think either of you are Mac people, but if you are, Matthew put me onto it. Our Matt, sweet. You can have a keyboard shortcut that pops up a window and asks your question and done. It's for certain kinds of searches. Um, quick answers back and forth. It's actually the least friction of any of the tools that I've tried so far.
Oh, that's a good shout. I just looked at it. Thank you.
Are you on a Mac?
Yeah, I'm on a Mac.
Oh yeah. Are you using Raycast already or not yet?
Oh, I wasn't using it. I was just checking it right now.
Yeah. It's a really fun rabbit hole. I use it for window management, spelling, looking up contacts, applications launcher. Matt and I had a thing on a Warpcast a week or two ago. What are you using it for? One of those quick conversations. And
But
he
is
mentioned the
everything
AI thing. So
local, or does it send your stuff online?
I'm pretty sure Raycast is phoning home. So
Okay.
I wouldn't use it for, I don't know. Right, that's an underlying thing for all of these tools, right? Claude's the only one that I know that doesn't phone home, that really to set out to guard you. I used ChatGPT and Claude together in concert, like giving this. I had a contract to review for a client, and I'm not a lawyer, but I can help a little bit, and I can at least make sure everything's spelled right. So something I've done for them for a long time, and I gave them, like you guys said, I uploaded the document in them plus Typing Mind, which is itself an interesting tool if you haven't tried it. Typingmind.com. And Typing Mind's kind of shtick is personas. So you can give it to somebody who's already trained up to be a good writer or a lawyer or a tech writer. A couple of different ones that I use. But I was able to get. Do you know the word concordance? You get the same document laid out in 6 different ways. I was able to take these 6 legal reviews and lay them side by side for my client so that he could scan them quickly and look for the issues that he thought were material. Because, as usual, all of them made mistakes. They point out things that were right when, were wrong when they actually were right. But then they also each of them caught something that was worth a look. and it's so I was able to help make that process less painful by and make it easy to compare. Giving it to 6 different interns and produce 6 different, not necessarily great, but still usable
I think
feedback.
most probably is it indie hacker typing mind, like some one person company.
Which one?
Typing mind, I think probably is a single person company.
He is one of these young entrepreneur types,
Yeah, yeah. I think it's
and
Tony Din or something. At least I see his pictures
yes,
on.
exactly.
Yeah,
I just upped the link in. Yeah. Well, and I
yeah,
I
yeah,
started. I got in early, and I didn't pay very much, and I have a lifetime license, so I'm happy that he continues
yeah,
to keep going.
yeah. He's a indie hacker.
He's claiming,
Yeah, yeah.
yeah, he's like Peter Levels, one of
Yes.
these fast moving types. But neither of you have tried it yet. I do think it's an interesting one to keep an eye on. In the greater scope of God
Well,
knows this is all gonna look like a year from
yeah,
now.
basically, I've been trying to learn. I've never done like web development, but I'm slowly trying to get those skills about what goes on in like to create a SaaS. Let's say if I have something, and if I want to create a SaaS platform or product, what are the components required? So I basically settled on at least one part of it. So I've learned a backend server like API serving framework now, so I can use that too. So I have been using it to create some APIs. So last weekend I created an API for a frame via that framework. So for the Yakro over Tumblr project. So I basically created a frame which would go to that server, and then I had some API endpoints. So I'm
I
basically
saw
trying.
that.
Yeah.
Yeah,
So
yeah,
I'm
and you really,
slowly trying to learn
yeah.
all these um, cloud
And
web
it's
development.
another composability project, right? Like
Yeah,
you had to bolt together, you had to glue
yeah.
together how many tools? 4, maybe 6?
Uh, well, the entire stack uh, was many. I think maybe 10 or something.
Oh, it was, yeah.
If
Funny
you
how they
include the
just
embedded
extend.
part, if you exclude the embedded part, then maybe it's like 4 or 5.
I dropped the link, by the way, in the chat. Bubble is another tool I've been keeping an eye on for these guys who are trying to build a tool that would help people spin up quick tools like what you described.
Okay.
Replete is the other one, of course, but everybody seems to
But
know
how
about
do you
Replete.
find all these tools? So I occasionally keep looking at those tool time channel. It's mostly your posts there.
I've just been doing this for so long, and by doing it, if I weed through tons of the separating the wheat from the chaff, you have to sift through a lot of chaff to end up with a few good pieces of wheat. So I don't know.
Okay.
I think I finally over time have set up tools like the inbound emails that
Yeah, so
just do some of the
basically,
curation for me.
your entire, like, I would say, social online media is tuned to these. So my media is tuned for embedded. So I might find stuff that other people in embedded or like other fields might not know that this thing exists for embedded. So my like entire online media is tuned for that specific uh, channel.
Yeah, yeah, that makes sense. And I'm more like open source DIY tools. I like the little guy.
I'm still trying to figure out what mine is. So
Yeah, not for you. We don't know you well enough yet, dear. That'll be fun. You guys,
Okay.
I like to drop their names once in a while. 100 Rabbits. Um, yeah, there they are. Let me drop that link. This is like my platonic ideal.
What? Vibe check.
100 Rabbits. It's 2 people that live on a sailboat making Linux software.
Wasn't it 3 people initially? Or have
Maybe.
they?
Last I checked, it was only 2. And so it's this, low tech website, but but really actually very well done, from a design perspective. They've got a couple of neat projects going that they slowly add to over time. It's slow computing, appropriate to computing. So the distant end of this big iron AWS kind of land, there's this other little stuff going on that I think is worth keeping an eye. For me, it's been fun and worth keeping an eye on.
So where are they sailing now?
Go look. I think they just set out. What am I thinking? They just set out from somewhere.
Oh, okay. They are sailing the Pacific Ocean.
Yeah, I think they're northern, like Canada is
Okay.
their
Because if you
base.
look at the map, they have gone from Japan to Toronto, or is it Toronto? No, what's the Vancouver? Yes, the other side.
Vancouver, that's what it
Uh,
was. Yeah.
yeah, Vancouver, Japan, New Zealand. Okay, it's pretty wild.
Really, their website could be a model for the Yak Collective if it were one. I think it kind of is actually, where there are these long-running projects moving along at their own pace. There are the tools that they use. I've got it open again now. Be some interesting things there. Anant, I don't know where you're. Well, actually, do you want to stop the stream? Unrushed, because then I can ask Anant, where are you actually based? Let's
Okay,
be
so
safe.
we can stop for today. It's like
It's
nine.
time. Yeah.
Yeah.